what type of statistics are you going to need to plan in your analytic strategy section anyway, and how do you figure that out? It all starts with the data types, which we've already been over, but now let's build from there. So once you've figured out whether the variables you want to use are nominal, ordinal, interval ratio, whether you're going to sum or average them, those types of things, you need to be sure whether it's a categorical or a continuous variable. Your independent and dependent variables both. That's going to determine which statistics you're going to say you're going to do in your analytic strategy section. And if you were to actually collect data with this survey, you would do these types of stats. We're going to plan it ahead of time instead of just getting messy data and going, what do I do with it? Like sometimes happens in the real world with real researchers. It's best to plan ahead. So we are going to use that once we figure out exactly what kind of stats. We would figure out how many participants we need to say we're going to recruit in our participant section of the method section. So to read this chart, first I want you to look across the top to figure out what type, to make a decision based on what type of independent variable you have, okay? So all the green ones are tests that I would recommend. The red ones, not so much. They're going to be a lot more difficult to interpret. So it's going to be kind of hairy. You may have noticed if your independent variable is categorical and it has 3 or more levels, we're getting into some difficult territory there. And if your independent variable is continuous, that's good as long as your dependent variable is also continuous. That's going to be very easy to do and interpret. It's going to be very easy to write about and interpret. If your independent variable is categorical with 2 levels and you have a categorical dependent variable, you can do a chi-square test, just like many of you already did on your group projects. The other easy types of tests to do are t-test and ANOVA, and even though we're not actually doing them, they're going to be easier to talk about and interpret. So overall, count your independent and dependent variable. I recommend such that your independent variable is categorical with 2 levels, or you pick a continuous independent variable, a continuous way of counting it, and your dependent variable is continuous. So those categorical dependent variables make things a lot more difficult. So stick with a continuous one if you can. It's possible to do otherwise. It's just going to make your life a little bit tougher. So t-tests, ANOVAs, and correlations are ideal for this project, especially correlations and t-tests. But you might have a third variable thrown in, not just your independent and dependent variable, and not every person's going to have this in their survey project. This is optional. Now, this is optional only in certain cases where you have a strong theoretical reason for expecting something like this to happen, and you will find this as you're reading the literature, writing your introduction. Okay, so imagine that I was doing a study like the little survey one we've looked at, where I wanted to test a relationship between the amount of time spent on social media and how that affects people's happiness. And let's say that I had read an article that suggested older and younger people have different emotions about when they use social media. So they feel very differently about it. Age is a third variable that might screw up me testing my hypothesis, okay? And I want to kind of account for it or almost like remove its effects so I can really look at social media and happiness, like the amount of time you spend on there and how you feel. Let's say I hypothesize that grades are going to be higher in face-to-face classes, but I read an article that suggested some students do better and do super well in online classes because those particular students have great time management skills. The ones who don't have good time management do better in face-to-face. So students' particular time management skills, that's something that might screw up the relationship between my independent and dependent variable. So if I have a strong reason to believe that might interfere with me testing my hypothesis in the study that I'm proposing and planning, I may want to add this third variable into my analysis, and that's called a covariate. It's not my independent variable. It's not a variable of interest, but it's one that might mess up me testing my variables of interest. So I want to account for or kind of remove its effects. So this will modify your statistics plan a little bit, and I've made another handy dandy table to show you how it would and which test that would cause you to end up with. So if your original test is a chi-square, I advise not adding a covariate at all. That's going to make stats kind of tough. If you had a t-test because you had a categorical predictor with only 2 levels and a continuous dependent variable, if you add a third variable, If it's a continuous one, like age or something, that could be very useful. It would make an ANCOVA, which is not too super difficult to interpret and plan. So that's one I would encourage. If you originally had a one-way ANOVA, you can also add a continuous predictor and make it an ANCOVA, which is not too super difficult for us to do. If you had a correlation, that's the easiest one to interpret if you add a continuous or a simple two-level categorical independent variable. So again, this is optional only if it makes strong theoretical sense, and the easiest covariate tests to interpret are one-way ANCOVA and multiple regression. But if you've already picked a type of statistic, there's still one more step. You have to narrow it down just a little bit more. If you have a t-test, a categorical predictor, so two groups of participants you want to compare to each other, there's two different types of t-tests. There's a dependent groups and independent groups. Dependent is only used in special cases when you have a within subjects design. So your two groups is really the same group of participants who took a test two times, pre-test, post-test design. You would use a dependent groups, or it's also called paired samples t-test. Or even if your participants are two groups of people, two different groups of people, let's say I had to match them because random assignment didn't mix up their demographic characteristics very well. It kind of left them too clustered in a small sample, and I had to match them, which means participant one in the control group has an age and race matched person in the experimental group that's sort of their like counterpart, and I'm matching them and comparing specific people to each other, then I would use a dependent samples t-test. But the default, and the one you're probably going to do, is if you have a between subjects design. You have two groups of participants who are separate groups of people and they don't have any particular connection to each other. That is a between subjects design. Maybe they're already separated into these groups, taking face-to-face versus fully online classes, or maybe it's something you assign them to if you're coming up with an experimental design. Either way, independent samples t-test is the way to go there. There are different choices for ANOVAs too, which is if you had a single which is if you have a categorical independent variable, but it has three or more levels. Like if you measured gender with a non-binary category in there, and that's a predictor you were interested in looking at, and you had a continuous dependent variable still, you would use a one-way ANOVA. That can be within or between subjects, just like your t-test. But the within subjects one, you're probably not going to use again, but that would be your one group of participants taking the same test three or more times. And that would be called a repeated measures one-way ANOVA. If you had instead three separate groups of participants who all took the same test, that would be a between subjects factor, and that would be just a regular plain old one-way ANOVA. You can also have an ANOVA with two independent variables that have two or more levels, but I discourage you from doing that. So maybe don't add a categorical covariate in this situation because it's a little difficult to interpret interactions and stuff. An ANCOVA is the same as an ANOVA in terms of making decisions for the categorical factor. Your independent variable that's categorical could be either within subjects, which is repeated measures, or between, which is plain old ANCOVA. But I believe the only option we'll have in future steps we need to take is going to be the regular between subjects and COVA anyway. And the fact that there's a continuous predictor in there doesn't matter. Your continuous covariate, you don't have to make any special decisions about that. You also don't have to make any special extra decisions if you already had just a correlation, multiple regression, or a chi-square test as your planned analysis based on your data types. So to sum up, those data types and which tests they correspond to, again, real fast, I have created this master table, this master list of those, where just in case looking at the other two tables was difficult, I picked just the ones that I recommend here, and their names and which types of independent variables lead you to needing that type of test.